Good morning, everyone. And first, I just want to thank the NSTF for inviting me to come and share with you the work we are doing at SCION that promotes research within the environmental sustainability area. Can I move? I think I thought I should first just talk about who we are. So SCION by itself is not a business entity, but rather we are a business unit of the National Research Foundation. The NRF manages 3 national facilities. 2 of them work within the Earth and Environmental Sciences. And these are the South African Institute for Aquatic Biodiversity, SIAB, as well as ourselves as SCION. And we also have a business unit that focuses on nuclear science, that is the Timber Labs. And we have 2 national facilities that focus on astronomy, and that is these are the South African Astronomical Observatory, as well as the South African Radio Astronomy Observatory, SARAO, that you may know because they are responsible for implementing the Square Kilometer Array project. Regarding SCION, we were established in 2002, and with our establishment, the idea was that a national facility was needed that would focus on environmental sciences. But then keeping in mind that we are under the Department of Science and Innovation. So the idea is that we need to assist with driving research within this area. And our vision is to provide world-class environmental research platforms for a sustainable society. I like to show results from the Global Risk Report because they show the importance of focusing on environmental sciences. Every year, the World Economic Forum publishes this report, normally in January. They conduct a survey where they talk to specialists across a number of disciplines, and they ask them, what do you consider as the risks that we will be grappling with, as a society? And in the past few years, the environmental aspects have been coming up right at the top. So these are ranked according to likelihood of occurrence as well as impact. And based on that, they determine which are the top 10 global risks that we are likely to experience. You'll see there where I'm showing the 2023 report. With this particular one, they asked questions, what are the global risks in the next 2 years? And they also asked what are the global risks that we will be experiencing in the next 10 years. And what you see there just coming out with the 10 years is that we actually 6 of the top 10 risks are actually environmental in nature. Those colors, blue is economic, green is environmental, orange is geopolitics, red is societal, and purple is technological. So the environmental sector is actually very important for us to really work on because it links very directly to socioeconomic benefits. We've all know the words climate change. It has come out in almost all the presentations because it's really one of the challenges that we are dealing with. The Intergovernmental Panel on Climate Change have been publishing a lot of these reports. And in the past 2 years, they published their 6th assessment report. The report has shown that there is more evidence indicating that indeed our activities have contributed to the occurrence of climate change. We have increased the concentration of greenhouse gases in the atmosphere. And as a result of that, the atmosphere is holding on to more heat than it's supposed to. And as a result, we've got climate change. The nature of the extreme weather events are changing. We are seeing droughts that are occurring. With the natural disasters in South Africa, you are aware we've had a few of them being reported. Last year in KZN, there was that flooding event due to a cut-off flow system that resulted in the death of over 500 people. There was an international community of international, team of scientists that did an attribution study on that particular event, which indicated that climate change actually exacerbated that event. So I mean, part of the climate change, especially some of them would actually focus on the impacts. And what I'm showing you here comes from the working group 2. This is a report that was published last year in February, where on the first column looks at water security and food production, and the second one talks to health and well-being. And then the third column talks to cities, settlements, and infrastructure. You see plus signs there, and then you also see negative signs. Where you see plus, the team of scientists that were working on this concluded that climate change will result in positive impacts. And where you see negative, it means this team of scientists concluded that climate change will result in negative impacts. You'll see on the left there is global, and then just after global there's Africa, and then there's Asia. So just focusing on that Africa line, you can see there is not a single positive. So what that means is that for us, climate change will just result in adverse impacts. So we will be impacted in terms of our water security, in terms of our food security, in terms of our health and well-being, and our cities, settlements, and infrastructure will be impacted adversely because of climate change. So one of the ways to deal with some of the impacts of climate change, but basically going towards being resilient, is through the use of early warning systems. And this is something that is also recognized at the UN level, to the extent that last year on World Meteorological Day, 23 March, the UN made an announcement that by the year 2027, they would like to see everybody on Earth having access to early warning systems. In Africa, we are told that it's only about 40% of the population that has access to early warning systems. So there's a very high percentage that does not have access to these early warning systems. And in order for us to develop these systems, we actually need to monitor what is happening in the environment. And that is because there is an actual value chain that is followed to develop such early warning systems. The World Meteorological Organization came up with an implementation plan that they have costed, that the amount of investment that is needed for us to make sure that everybody has access to early warning systems. And it's very clear that for us to develop such systems, we need to understand the risks that we are exposed to. We need to have observations, long-term observations, so that we are able to see if there are trends that we can observe, if there is variability that we can observe from those observations. And we also need to use models to be able to forecast. And when the early warning, so when the information becomes available, it has to be disseminated and communicated. A perfect early warning will be useless if people that need to respond to it do not receive that information. And then following that, we also need to be prepared. If you get a warning that says there's going to be flooding and you are staying in your house, the question is, in terms of response, how do you respond? So we need to also be prepared to respond to those warnings as they are coming out. Yeah, so one of the very important aspects of these are observations. So we need observation networks that will tell us this is what is happening right now. This information is also used in models that require data to force it. So in numerical weather prediction, we call them initial conditions. So it's observations that you feed to the model, and then to allow the model to be able to run to produce those forecasts. The map that you see there that is colored there, that has many colors, those were observations that were sent on 30 July 2023 to a center in Europe. It's called the ECMWF, European Center for Medium Range Weather Forecasting. So these observations are used as input towards numerical weather prediction models that are running across the globe. And these models inform the weather apps that you have access to on your phone. So these forecasts are based on these models. But what I want you to notice there is that in the Southern Hemisphere, the observation network is actually sparse. So we don't really have much in terms of the observations in the Southern Hemisphere. And then if you look across the African continent, you also see there are actually a lot of gaps. South Africa looks rather impressive when you see there's actually a lot of red there. So those are observations that are coming from the South African Weather Service being sent to the ECMWF to inform these numerical weather prediction models. But all in all, we are not doing well for if you compare us to the US or if you compare us to the rest of Europe. So we actually do need to do better in terms of our observation network. I'm showing you just the covers of the State of Climate in Africa reports. So since 2020, these reports have been produced by the World Meteorological Organization working with UNECA, where they will list the disasters that have been reported and the impacts associated with them. And each and every year, these reports keep saying we need to work on our observation network. And this is something that is really not improving as well as we would like to see happening across the African continent. Slide. So here, what I'm showing, because there are people that when you tell them that there is a need for in situ observations, we need to take observations on the ground, they will tell you that satellites will do the work. And the first thing to mention is that indeed satellites do help. That first figure, the one at the top, it shows the forecast, basically the difference in forecast skill between the Northern Hemisphere and Southern Hemisphere. I showed that the Southern Hemisphere has less observations. And you can see there's a point where the two lines just converge. And where you see those lines converging, that is when we started introducing satellite information into these numerical weather prediction models. So the use of satellite information has indeed helped. But we need to realize that with some of the information coming from the satellite products, some of these are products that need to be calibrated with ground observations. The figure below there shows you a completely different figure. The example I'm showing is on a specific date, 18 February 2017. What I'm showing you there is 24-hour rainfall. So the one is actually ground observations from Botswana. This particular study was actually focusing on Botswana. And then on the right, there is IMEC. So that is a rainfall product from NASA. Below that is TAMSAT, which is a rainfall product from University of Reading, and then left of that, we've got the ERA5, which are the reanalysis from the ECMWF. So all those figures are supposed to say on that specific day, did it rain or not? And actually the meteorological community uses this data as observations. And you can see even when you look at South Africa, for example, if you compare the ERA5 reanalysis to TAMSAT as well as IMEC, just looking within South Africa, you can say ERA5 says there was some rainfall which was observed. While the other products say actually there was no rainfall. And the reason that we are seeing this is because we don't develop these products ourselves. Secondly, it's because we do not have enough ground observations that are assisting in the development of these types of satellite-based products. Hey, so now the question would be, if now we are to say in South Africa, we need to make sure that we've got observations, what are we looking at? And you can see that it's actually a whole lot. I mean, it's our 52 districts and metros. And actually, ideally, you really want to have high resolution when it comes to these observation networks. You want to make sure that the distance between the different observations is actually close to one another. And as a country, we're also responsible for what's called the Met Area 7. So you can see the Atlantic Ocean, the Indian Ocean, and going all the way to Antarctica. So we should also be collecting observations in those areas. What is happening in the Atlantic Ocean has an impact on us. There are, for example, cut-off flow systems that start in the Atlantic Ocean. They come and they make landfall over South Africa, resulting in heavy rainfall events. There are like cold fronts that start in the Atlantic Ocean. They come, they pass over. So it's important that we are able to take observations in those areas. In the Indian Ocean as well, it also impacts us. The South Indian Ocean Basin is one of the basins where tropical cyclones form, and tropical cyclones can make landfall over South Africa. There is a very famous example, Domoena, which made landfall in KZN, Domoena and Imbo and KZN around 1984. Although most of the tropical cyclones make landfall in Mozambique, South Africa can also be impacted by this. So it's important that we have observations also coming from the Indian Ocean. So here I'm just showing you what we have in terms of landscapes within SCION. I think the thing to notice, I mean, if you look at our observation network and you compare perhaps to what the ARC has or what SORS have, you will realize that we are not that dense across the whole country. And that is because we are under science and innovation. We are supposed to drive research. So the way our landscapes have been chosen, they were selected actually really carefully. The different colors are different biomes. So we try to cover different biomes in South Africa. And then secondly, we try to cover, the areas where you are really high. So in terms of topography, high up in the mountain. And we also try to go all the way to the coast. So you can see there is a landscape right attached to Lesotho. There is our Cathedral Peak landscape. So that means right up there in the mountain, it's a strategic water area actually for the country where we are taking observations. We are looking at what is carbon doing. We are looking at what the different biomes, the impact of different biomes in terms of water availability. So as SCION, we are not trying to take observations across the whole country, but we have selected very specific sites where we have a dense observation network. And that's just one point of Cathedral Peak. We actually have 33 rain gauges. We've got 4 automatic weather stations. We've got 2 flex towers. So the idea is that these observations, as we take them, will then inform the development of satellite products. They will inform the development of models as well. And with some of our sites, we also work with the communities. The example that you see right next to the Indian Ocean, that is where we've got Maputa land, and we are working with the communities. They're looking at the plants that they are planting there and how those have an impact on their water availability. So some of our sites are right in the nature reserves that you could say are really pristine, and we can really study what the environment is doing. But with some of our sites, we also engage with the communities and ask questions about in the way that they're engaging with the environment, is that sustainable or not? And the Maputa land is actually a very good example. We were celebrating the SCION's 21st anniversary last month, and we had the Inkosi from Maputa land attending our event. It was in Cape Town. He flew all the way down to Cape Town to our event, just showing how, the value of SCION working with that community there. Thanks. Next slide. So there is also the South African Research Infrastructure Roadmap. The SARIR program is being implemented by the Department of Science and Innovation. This program was launched in 2016, and the idea with SARIR is to implement medium to large research infrastructures, because for us to be able to do research, we need research infrastructures so that we can avoid what is normally called the suitcase science, where scientists have to go abroad to be able to conduct their science. So we keep taking samples and we are sending them abroad. So the idea with this is that government is really putting a lot of investment to make sure that South African research is competitive. There are 13 research infrastructures that have been identified so far. They are in different stages of implementation. Within SCION, we are responsible for 3 of these research infrastructures. For the environmental sector as a whole, there are 5 of them. The ones that you see actually shown there in green, the natural science collection facility, I believe, is with Sanbi, and then the biogrip, the one that's shown there as number 9, is hosted by the Northwest University, while the 3 that you see there that are in bold are being implemented by us at Sion. So this is just to show you in short what the 3 that we are responsible for look like. We've got FT1 that focuses on terrestrial sciences. So the observations that we are taking, looking at water availability, water quality. We are looking at the biodiversity in terms of plants. I mean, we really go and mark plants and so that we can check them as they are growing, see how they are doing. We would like to work with the communities, and there are 6 landscapes that have been identified. And there was a really thorough proposal writing. The scientific community was involved in this. There was an initial about 50 proposals that were submitted, and then they were shortlisted to 20. And then following that, there were much longer proposals that were written up, and then out of the 20, only 6 have been selected. And these are the sites that we have at the moment where we are going to have flux towers, and we will take a whole lot of observations. So we're interested in what's happening with water. We're interested in what's happening in terms of the biomes. We're interested in working with the communities. We're interested in the meteorology as well. Then the second one is called the Shallow Marine and Coastal Research Infrastructure. So this is really being run from our office in Gqeberha, and it's also been implemented since around 2017. We've got labs where we can check the nutrients in water. We look at the water quality around the Eastern Cape. There are 4 sentinel sites that we are going to be setting up. There's Algoa Bay, which is the longest running ones, but we'll be setting up other sentinel sites in Cape Town, in Durban, as well as in Marion Islands, and then we'll also have some sentinel sites. So we do go into the oceans. In terms of the observations that we are collecting, we look at the sea surface temperatures, we look at the water quality, and we also take observations of the biodiversity that is inside water, but focusing around our coast. Then we've got the South African Polar Research Infrastructure. So the 2 that I've just mentioned, we've been hosting them since 2017. So the South African Polar Research Infrastructure, we only started implementing it from November 2021. And it's got different components. There's a polar lab that's being implemented by University of Cape Town. We've got a data processing and society nodes that's being implemented by University of Stellenbosch. It's got different components: long-term observation land, which would focus on Marion Island as well as Antarctica, and we've got long-term observation ocean, where we just go out into the oceans and then we take observations. In May, we had a cruise that went out for about 9 days. We went into the Atlantic, where observations were made of different biodiversity that's available there. Then just in terms of the numerical model, I've already mentioned that to be able to have forecast, because I'm a meteorologist, I can speak to that with the observation, like satellite information or weather radar information, you can only predict up to about 2 hours. Beyond that, we rely on numerical weather prediction models, and they are based on the types of equations that are there: conservation of momentum, conservation of energy, conservation of mass, all of that. And these actually require the use of high performance computing facilities. Within Sion, we've got servers that are available that we use, but if we want to run really big models, we rely on the Center for Performance Computing, which is hosted by the CSIR. When we run our models, ideally, especially the output that you see as part of climate change projections, you actually want to have different aspects of the Earth system being represented. You want to know what's happening in the ocean. You want to know what's happening with your land surface, and you also want to know what is happening with the atmosphere. And that in itself makes these models really expensive to run. So there's also that component of modeling that we are contributing to. We've got a team that's based in Cape Town as part of the eGagasini node, as well as the SAPRI research infrastructure that I've mentioned. that are running an ocean model. We are doing this. You can see we've put the logo of the BFFE, and that is because we've got a project with them where we are running a model around the Algoa Bay. So just to predict what is happening in that area, that information is then being put on it is being put on a website for people to access that information to be able to make decisions. Next slide. On this one is just to speak to the issue of model development. I mentioned when I was showing the figure based on satellite information that some of the issues we are seeing probably have to do with the fact that we don't actually develop these products ourselves. The same applies. So the models that are used right now to produce weather forecasts, the models that are used to produce climate change projections, none of them were actually developed on the African continent. And when we run these models, we find that they've got shortcomings. When I was with the South African Weather Service, the model that was used there, we made a comparison between the simulations of thunderstorms and weather radar and found that the model that's used there, developed in the UK, is not able to produce the intensity of our thunderstorms. There was a study that was conducted where a model developed in the UK, the same one, the unified model, and a model developed in the US were compared in Australia, where there was not much in terms of, there was no big weather system. And they were checking how do these models perform, and they found that both models did not produce what was observed. The one developed in the UK produced some intense thunderstorms every day in the morning, while the one that was developed in the US produced a big, like a mesoscale convective system in the afternoon. And they thought that is actually informed by the interests of the people that are developing those models. So that in itself says if we are not developing our own, then our interests will not be represented in these models. So we will keep saying the models do not do well in our region. So there is a program that we are working with. We are working with University of Witwatersrand, University of Pretoria, University of Limpopo, to try and build capacity around the development of these models. But the progress is not going as quickly as we would like. However, we want to make sure that South Africa develops its own models, perhaps, collaborating with other African countries. Here, I think that just the first point to make is that all the observations that SION observes, or all the observations that we are taking are available for you to download on our catalog. I know it's actually an interesting area when we talk about data policies, because some organizations do sell their data. One in our case, and specifically because we are under science and innovation, we really want to catalyze, research. So we don't sell our data. If you want to have access to the observations that we are collecting, you can get in touch with us. Some of the data is already available on the catalog. We have products that we have got available, including atlases that are available on our platforms. We are, for example, hosting the South African Risk and Vulnerability Atlas, SARVA. And on our platform, if you run a project and you want to make your results available to the public, perhaps you also want a GIS interface, we do provide that. So you can engage with us and we can work with you to make sure that the information that has come out of your project becomes available to the public. And that is actually important to mention, because if, for example, you talk about open, there's a talk around open science and the fact that data needs to be available to the public. If you do not have a platform to make that data available, actually that policy would not work, because you really don't want a situation where you get bombarded with a lot of emails, but you need a platform that can make it possible for people to access your information easily. And then secondly, we also can upload data that is provided. There are farmers or some specific individuals that have got, weather stations in their homes. If they want to share that data to the public, that data can also be uploaded onto our system so that it can be made available to people that are interested in it. We've just received certification I forgot now what is called, cultural seal. We've got certification. So Scion's repository is considered, one of the best in the world. So across the whole African continent, it is only Scion and UCT that have got this particular certification that we have just received as Scion. Yeah, so here it's really just to say what are we doing. So we are engaging with school learners. So we've got nodes distributed across the country. We've got 8 actually different offices. I've got an office in Palabora, in Pietermaritzburg, Kimberley. In Cape Town, we have 3 offices. We have an office in Gqeberha, and we engage with the schools in those areas. We engage with the educators. We run a lot of educator workshops where we will teach them about the biomes of South Africa. We also run educator workshops where we will teach about GIS. And actually the 2 that I've just mentioned are accredited by SACE, South African Council of Educators. So that is a training that we are working actually very closely with the DSI to make sure we go to the schools and engage them. We also have the graduate student network. So once a year we run what we call an Indivano. So this year's one will take place next week in Cape Town, where we get about 30 to 40 graduate students to meet. They present on their work and we give them an opportunity to talk to each other about their research, but we also provide training on things such as Python, QGIS and R. And our scientists also lecture in different universities, so they've got affiliations with different universities. There's a program called Putlisa, which is being run by SIAP, which I said is basically another business unit. It's a national facility of the NRF as well, which is focused on making sure that we increase the number of students that take on marine sciences. So we are contributing to that Putlisa program to increase students that take on marine sciences. I just want to mention again that our landscapes are available for use by the scientists. They are available for use by the students. You really just engage with us and then we can provide access to that information. In terms of the data, as I mentioned, it's available for you to download if you're interested in it. Okay, that's fine. Yeah, so this is just really the concluding remarks where just in summary that, within Scion, we are interested in what's happening in the marine environment. We're interested in the terrestrial sciences. We are interested in what's happening in the atmosphere. And I'd like to believe just from the initial slides that I showed that in terms of the global risks that we are expected to have, they are environmental in nature. And therefore, through our work, we are really able to make a difference when it comes to socioeconomic benefits.